Hey everyone, so today we're going to talk about ions. We've already talked a little bit about valence electrons, but we're going to talk about how that drives ions that atoms form. This whole unit is all about bonding and how different elements interact with each other and how different molecules interact with each other. And a large part of that has to do with the ions that things form. So we're going to talk about how to know what ion an element will form. As well as we'll talk about what polyatomic ions are and how to name different types of ions. So we've already talked about valence electrons in the past. Hopefully you already have this in your notes. Valence electrons are those electrons in the outermost energy level of an atom. And these are the only electrons that we care about when it comes to bonding. All of those ones in the lower rings closer to the nucleus, those don't really matter. Those play a role in the properties that an atom has, but not in their bonding. We've also talked about the octet rule and how all atoms want to have 8 valence electrons, which means they want to have all of the electrons in their s orbital and all of the electrons in their p orbitals in the outermost ring. The goal is for them to have 8. Noble gases, which are the ones in the very, very end that start with the helium column, they already have 8. So everybody else, their whole goal in life is to either hold on to electrons, steal electrons, give electrons, whatever they have to do to have 8, just like the noble gases. And it's their electronegativity and their ionization energy that predict that. The exceptions to the rule, of course, are hydrogen and helium. They don't want 8 because they've only got, well, in hydrogen's case, it's only got 1 electron and helium only has 2. So they only want 2. 1s can only, there is no 1p, so 1s can only hold 2 electrons, and hydrogen and helium are happy with that. So if you have not already labeled the valence electrons on your periodic table, I would take a moment to do that right now. Everything in this first column has 1 valence electron. Everything in the second column has 2. The things in the middle don't matter. Technically they have 2, but that's not what drives their bonding, so we don't really care. Everything in the column that starts with B has 3 valence electrons. The carbon column has 4, the nitrogen column has 5, the oxygen column has 6, the fluorine column has 7. The noble gases over here have 8. The exception to that is this helium right here. You might want to make a note of that. Helium only has 2 because it only has 2 electrons. So a good way to visualize the valence electrons, which will help us to visualize, I don't know why this says double line, it will help us to visualize the valence electrons that an element has, and so we can look easier at the ions that they're going to form and how they are going to bond with other atoms. So the first thing you would do is write the element symbol, and then we would figure out how many valence electrons it has. And then we're going to picture it in a box, and we're going to put dots around it to show its valence electrons and which electrons are available for bonding. So let's look at this as an example. So let's take nitrogen. Take a look at your periodic table and see how many valence electrons nitrogen has. Right, so it has 5 valence electrons because everything in the column with nitrogen has 5. The next thing we're going to do is we're going to write the symbol, which is N, and we're going to picture this box. You're not going to actually draw a box. I just want you to visualize we're not just putting dots anywhere we want around this. We're going to picture a box where each side can have 2 dots. So the first valence electron we'll put here. It makes no difference at all which side you start on. You can start anywhere. I'm starting at the top just because. So you'll start with 1 dot, and then we're going to continue to add 1 on each side because electrons like their space. So we're going to do 1 on each side. Now we're at 4, and then we need to add 1 more. Doesn't matter which side we double up on. And so now we've got 5 electrons around nitrogen. So we're putting 1 on each side before we double up. It makes it easy for us. So the electrons, their goal when they're bonding is to find a buddy for all of their lone electrons. So like nitrogen here has 3 lone electrons, which means its goal in life is to find 3 buddies to match up with these electrons. Another element that has, or other elements that have lonely electrons that they can buddy up with. Because helium only has the 2 electrons and they're both in S, they're already buddied up. So the one exception for Lewis structures is the 2 electrons in helium you would put together on the same side rather than individually. So take a moment and see if you can figure out the Lewis structures for these 4 atoms. Hopefully you've come up with this. Carbon has 4, so 1 on each side. Calcium has 2, so we're just going to show 2, not together, 1 on each side before we double up. So when we want to figure out what kind of ion an atom is going to form, they're gaining or losing electrons to have that full outer energy level, which means they want to have 8 valence electrons. Elements that gain electrons have a negative charge, remember, because they're gaining negatives, and we call those anions. Elements that lose electrons have a positive charge, and we call those cations. If an atom only has 1 or 2 valence electrons, most likely it's going to want to get rid of those electrons. Once it gets rid of the electrons in its outermost ring, now it's got a full ring underneath. So typically they will lose those electrons to form a 1+ or 2+ ions. So with a charge of +1 or a charge of +2. Aluminum typically forms a +3. And the way we name these cations is just with the name of the atom. So for example, calcium, it has 2 valence electrons, which means it's probably going to lose those 2 electrons to become calcium 2+, and we just call it the calcium ion. For anions, those are atoms that only need to gain 1, 2, or 3 electrons. And so to name these, we drop the ending of the element and replace it with "ide." So fluorine has 7 valence electrons, which means it's going to want to gain 1. And so we'll call it the fluoride ion. Nitrogen has 5 valence electrons, so it's going to want to gain 3. And we call this the nitride ion. I'm not going to grade you on whether or not you know exactly where to put the "ide, but just try saying it in your head. Like nitrogenide is kind of a mouthful. So kind of say it in your head and decide where does the "ide sound like it should go, and do the best you can with that. The transition metals, as I said, their valence electrons don't really drive how they bond. So we need another way to tell us how many electrons are available in that element for bonding, or what charge those ions are going to have. Most of them can have several different charges, and so we use Roman numerals in order to express which ion we have. So for example, if we had an iron 3+, which means it has lost 3 electrons, we would call it iron 3. If we had iron 2+, this means it's lost 2 electrons, and we would call it iron 2. You might want to look up your Roman numerals. We won't ever go above 5, but you should be able to recognize those Roman numerals. There are a few exceptions. The zinc ion is always 2+, and the silver ion is always 1+, so you don't need to write the Roman numeral. You should make a note of that on your periodic table, maybe a little in the squares for zinc and silver, because also when you see the name, you won't see a Roman numeral and you'll need to know what its charge is. Lead and tin are not transition metals, but they do form more than one ion, so you do need to write Roman numerals for those. Lead is Pb. I'm going to put those in there because they're not intuitive. Lead is Pb and tin is Sn. So you may want to make a little note on your periodic table for those as well, that you will need the Roman numerals. So let's give it a try and see if you can name these ions and write the symbols for the ions with their names. Right? Hopefully you got these. All of the positive ions are just the name of the element. So sodium ion, aluminum ion. Copper is a transition metal, so we needed this too. And then our negative ions, we changed the ending to "ide," so oxide, chloride. Down here, magnesium is in the column that has 2 valence electrons, which means it's going to lose 2 electrons, and we'll have Mg2+. Chromium, we don't know what ion it would form because it can form more than one. So they told us with this 2 in Roman numerals that it tells us that its charge is going to be 2+. They're all plus. Those Roman numerals, these transition metals will always be positive. So it'll be 2+, 1+, 3+, whatever the Roman numeral is. And sulfide, if you look on the periodic table, sulfur has 6 valence electrons. So it's going to want to get 2 more in order to have 8. And so it would be sulfur 2-. These ions are all called monatomic, meaning they have one single ion, or one single atom, I'm sorry. But they can be made up of more than one atom, called polyatomic ions. So for example, the nitrite ion is NO2 with a -1 charge. The sulfate ion is SO4 with a 2- charge. You actually have this chart on the back of your periodic table right now. So if you see an element or an ion, say OH-, and I asked you for its name, you would say hydroxide or hydroxide ion. If I asked you to write the symbol for hydroxide, you would write OH-. And these are, as I said, right on the back of your periodic table. Hopefully this is pretty clear. If you have any questions, you can ask me in class next time we have class, or on Friday during office hours, or you can send me an email. The next assignment you'll have is actually naming some of these ions and predicting what their charges will be and writing some of their Lewis structures. So have a great day.